Hi guys, it's Mrs. Allison again. I am back to show you how to solve systems of equations by elimination. And just like before, the time that I would choose elimination would be when my equations are set up in standard form. So we have an x plus y equals some number. And the time I would choose elimination would be the time that I don't have a variable already by itself. I mean, I could potentially choose substitution with this first equation because the x is kind of by itself. It's not quite there. But I would still choose elimination on this one, not substitution. So here is the process we go through for elimination. And I'm going to write a few notes down. When we use elimination, there is two things that we need. We need to have the same coefficient, which means the number in front. Let's see if I can fit all this in here. Same coefficient, but I want the opposite signs. Opposite signs. Okay, so the reason that's important is because if we're going to eliminate something, we need to cancel it out. And the way we can cancel out, say, a positive 2 is with a negative 2. Those two numbers eliminate one another. So what we need to do is we need to get a coefficient, which is a number in front of the variable. We need to get a coefficient that is the same, but where one is positive and one is negative. So you have two choices. I can choose to make the x coefficients the same but the opposite signs, or I can choose the y coefficients. And in this particular problem, what I notice is it would be really easy to make a single x eliminate with a 2x. Those two would be very easy to eliminate. So to use elimination, what I'm going to choose to do is I'm going to choose to multiply this first equation right here by a negative 2. So this is what it would look like. I would take and multiply this entire equation here by a negative 2. Now, why did I choose negative 2? I chose negative 2 because when I do my multiplication, and remember this needs to go to each number in that equation, this gives me a positive 2x, a negative 10y, and it equals a negative 46. So look what happens. I now have a positive 2x from right here, and then if I repeat that second equation, it would be a negative 2x minus 7y equals negative 22. So you can see right here, I have the same coefficients, but opposite signs. So now what I do to continue on with my elimination process is I add the two equations together. And what I'm going to do is I'm going to combine like terms, and look what happens. Positive 2x and negative 2x, they eliminate. They equal 0. That was the whole point, was to eliminate a variable. Then I'm going to take and combine a negative 10y and a negative 7y to give me a negative 17y equals, and then a negative 46 minus 22 gives me a negative 68. Okay, so now I'm going to continue on with my process of solving, and you'll notice now I'm down to one equation and one variable, which is much easier to solve. So I'm going to go through and I'm going to solve this for y by dividing both sides by negative 17. And then we're going to get y equals, oops, I said negative 17. There we go. And then we're going to go and get y equals 4, because negative 68 divided by negative 17 is 4. Okay, just like before, we're not done just because we know one of the variables is 4. I need to go and solve for the other variable that I didn't already solve for. So in this case, I need to go and solve for x. Now, I go back to the idea of substitution. So in this case, with y equaling 4, I can go back into either the first equation or the second equation. I could even go back into the multiplied equation, but that would be silly to add more numbers. So I can choose either the first equation or the second equation to take my y back into, and you get to pick whichever one you think looks easier. So I'm going to choose that first equation. So I'm going to go back in to the equation negative x plus 5y, and I'm going to put parentheses for my y, equals 23. So in place of y, I'm going to put what y equals, which is 4. So now I'm going to go through and solve, and I get negative x plus 20 equals 23. Subtract my 20 from both sides. I get negative x equals 3. And then I'm going to divide by negative 1 to get x equals negative 3. Lost my equal sign. So x equals negative 3. And just like before, my answer is expressed as an ordered pair. So the answer to this problem would be negative 3, 4. And again, it would not be a bad idea to go back and check your work just to make sure that this answer works for both equations. Okay, so what happens if it's not as straightforward to multiply just one equation by a number? So let's look at these two equations here. I have 5x plus 3y equals negative 17 and 3x plus 5y equals negative 23. So sometimes with elimination, we can't just multiply one equation. We multiply both equations by something, and it does not have to be the same thing. So the same rule applies. We need to have the same coefficient but opposite signs. So what I'm going to choose to do here is I'm going to choose to multiply this top equation by, let's do negative 3. And then I'm going to choose to multiply this bottom equation by positive 5. So what good would that do me? Well, if you look and I multiply my top equation by negative 3 and my bottom equation by 5, I will be able to eliminate my x's. I think my mic got cut off. Okay, could I eliminate my y's? And the answer is yes. I just happen to choose to eliminate my x's, and that's all. It doesn't matter which one you choose. So let's go through and do the math. So let's start with multiplying that equation, that top equation, the one that's in red. And I'm going to multiply negative 3 by everything in that equation. That gives me negative 15x minus 9y equals 17 times 3, which is positive 51. And then I'm going to repeat that process and do everything in the blue. So that gives me a positive 15x, a positive 25y, equals 23 times 5, which gives me 115. Should be negative, 115. All right, now I'm going to go through the same process. I'm going to combine like terms, and that gives me 0x, which was the whole point, was to eliminate one of my x's. And then I'm going to do 25 minus 9y, which gives me a positive 16y, equals, then I'm going to do 51 minus 115. 51 minus 115, which gives me a negative 64. Okay, so see, I'm back down to one equation with one variable, and I'm going to divide both sides by 16 so I can solve for that y. And we get y equals negative 4. Seem to like the 4s today. And I'm going to take that y equals 4, and I'm going to substitute it back into one of my equations. It does not matter which equation. You get to pick the equation that you think looks easiest. And just for the sake, I'm going to go into that top one. So we would plug it into 5x plus 3 times my variable equals negative 17, and my variable happens to be negative 4. So I'm going to do the math, and we get 5x minus 12 equals negative 17. And I'm going to add 12 to both sides. Sorry, I had a moment where I wasn't sure it was going to work. Add 12 to both sides. And we get 5x equals negative 5. And I'm going to divide both sides by 5 to get x equals negative 1. So since this is a system of equations, I am going to write my answer as an ordered pair. So we get negative 1, negative 4. Hopefully that helps answer some of your questions on solving systems by elimination, and then the previous video, solving systems by substitution. Thank you. Have a good day.